Don't learn to code, not until you watch this video. Last time we talked about the logic and how even a calculator isn't really simple. But the point wasn't to make the program, but to think and strategize on a plan on how to make the program, how it's going to execute. Though, before we talk about the syntax, let's tackle some of your comments. Oli4740 says, cool video, but I hope you cover more of Boolean algebra later down the line since it is really essential. Boolean algebra is both logic and syntax and can be easily defined by train stations or electric circuits. The AND gate or clause dictates all conditions or switches must be on. Imagine it like a train wanting to reach a destination. If all switches are closed, then the train moves forward. Otherwise, it cannot reach the destination and can derail. Another way to see it is an electric circuit. Two or more switches in a row need to be closed for the light bulb to light up. The OR gate, or close, dictates that one of the conditions or switches could be on, or needs to be on. You need at least one train to reach the destination to be satisfied. So if any switches are closed, then you're good. Back to the electric current. An electric current with switches in parallel will only need one switch closed to light up the light bulb. You can argue that one train can derail into another path, or that the electric switch is a two-way, lighting up something else, which is the else clause, although that's later on during the video. The NOT gate, or clause, dictates that you want the other outcome of said condition or switch. Say the rail goes forward or right. Going forward means the switch is closed, although you want the switch to be open to move to the right. Or the electric current, you don't want to light the main light bulb. Looking back at it, I forgot to mention the syntax aspect of Boolean algebra. The aspect comes in the form of merging all of those gates in some way. For example, in between parentheses A and B or C isn't the same as A and in between parentheses B or C. While putting the conditions, you will make sure to know where to put the parentheses. Say for example, A, you're in a good mood, B, you can watch TV, and C, you can play video games. In case A, between parentheses A and B, or C, you will play video games whether you're in a good mood or could watch TV. On the flip side, in case 2, A and in between parentheses B or C, you will need to be in a good mood for either activity. In short, the placements of parentheses can change the entire meaning of the sentence. From Hutan. It's just simple math. Yeah, just 1 plus 1. Just 1 plus 1. From Nisaritu, joke's on you, I am too stupid to learn how to code anyways. We haven't even touched coding yet. Very soon. Let's move on to the syntax. The syntax is how the computer understands your text and how it turns it into zeros and ones that it can understand, reason why screaming at a computer doesn't really solve your problem, and how clicking on the on button turns it on. There are many coding languages, and to list a few, we got assembly, C, C++, C#, Python, Ruby, R, JavaScript, and no, HTML or CSS are not programming languages. It abbreviates for Hypertext Markup Language and Cascading Style Sheets. You don't program with those two. Say it again, you do not program with those two. Alright? Good. The language you use is not interchangeable, meaning if you write code in C, your C# interpreter won't be able to understand it or what it's used for. Like if you plugged a mouse to a freezer somehow. Both your PC and freezer run programs, but your PC would understand a mouse click and your freezer wouldn't. For simplicity's sake, this video will be in Python, and some C# if there is some edge cases that are not in Python, and only in C# and other languages. We will be looking at mostly syntactic phrasing of code. Do not feel pressure to learn what's to come. Focus on understanding the intricacies. Last video, we talked about how variables are boxes with labels, addresses, and types. In Python, variables don't have explicit types. You can hard define that type, although it is not required like other languages, such as C#. One detail in C# I need to cover is when declaring anything, you can private something or public it. A public declaration means that any later files having access or using that file can access it by calling it. As you can guess, private will not allow that access. This is called a scope. In Python, everything in the program is public, but not modifiable from everywhere. I will cover that later. In Python, type in x equals 5, creates a variable integer with the content being 5, x being the recipient of whatever the right side of the singular equal sign, in this case, the integer 5. The same can be said for C#, as you will need to type int x equal 5 and a semicolon, where the only difference is in case it's the first time you declare the variable in a non-Python code, you will need to predefine it with a type, and every statement ends with a semicolon, every single time. Back to the topic I answered in the comments. In hindsight, the majority of codes you'll write as a beginner will be a linear code. You will start your program to execute a specific set of steps to reach a specific output. For the example of the calculator, you don't need to calculate 1 plus 1 and 2 plus 2 at the same time, and even if you do, the operations aren't that heavy computational-wise. But zoom in on the execution line, you will see a bunch of threads, although all start from one place and intertwine, but the point of interest is mostly the reason it splits up, where it does and where it loops. Say for some reason your calculator asks for your name. The execution is paused until you answer. That's a train station where your program pauses until you fill the train with an input, but then the program asks for an operation you would need to execute. This can go 4 ways: addition, subtraction, multiplication, and/or division. The execution thread divides into 4 to account for all those possibilities. Those sub-threads can go long as the code needs to execute, and can even disconnect from the main thread if the program crashes or you quit the execution. Once you ask the user for the operation, say you write choice equals input between parentheses, quotation, addition plus subtraction minus multiplication x, division slash, that choice can later be used to see which thread to go to. Whether you check that operation using if statement or switch, let's just stick with the if statement. You write if choice equals plus, in between quotation, colon, and then go back to the line with an additional indentation signaling that you're entering the inside of a subthread. In C#, you open curly braces instead of a colon and indent your substatements to the same indentation level. This applies to most colons you will see in Python. You can also elif choice equals minus colon to add the subtraction, else if for other programming languages. Same for multiplication and division. You can also add a simple else without forgetting the colon at the end for cases outside your specific cases and cases that are opposite to the ones you already mentioned. This is called conditions, or as I like to call it, conditional splitting. Once the user wants to do an addition, you can keep asking the user for the same question over and over again while he doesn't exit, to keep asking the user for numbers to add, or for every number the user gives, add them up. You can see I've used 2 terms defining what is known as a loop: while and for, where the thread goes back to itself. A while loop runs the same code over an unknown amount of time to the coder. In this case, the person using the calculator program who's adding numbers together might add as many numbers as he wants, even with no limits. Say while imp exclamation mark equals 0, because why would you add a 0 to any other numbers? It's just adding nothing. You can do imp equals input, open quotation, give me a number, close quotation, close parentheses, and check that value every time to see if the loop should happen or not, or should end or not. What you do with the input is not important yet. On the other hand, a for loop runs somewhat known amount of time. In this case, the person asked to input numbers will give you a series of comma-separated values. To a certain degree, the user input cannot get longer compared to the while loop example. Say the user gave a list of comma-separated values to add. Separate those values by comma, say num equal num split by comma, and then the for loop will go over all those values such as val equal num. This will set val to each of the values in the loop and execute the following loop statements. In other programming languages, a do-while also exists, such as the condition is checked after the loop is executed, not at first. What I mean by that, say your banking app gives you the option to send money if you have a positive balance, and keeps asking you afterwards only if your balance stays positive. This is an example of a while loop. On the other hand, if you open your phone, you're prompted with enter your code at least once. If you fail, then you're asked again and again. This is a do-while loop example. This would be useful if you need the loop to execute at least once, no matter the condition. Although your code is all linear, some of it needs to be reused, re-executed with different parameters, and need results to those computations somewhere else. Instead of writing the same dozen lines of codes every time, you only do it once and invoke one line instead. Those are called functions. You define one using def, name it, give it arguments that will be needed to run the code every time. Say you made a function called sendMessage that takes 2 arguments, the person receiving the message and the message itself. You will have a list that checks if the person exists in the contact list inside of the function, and then some code that connects to said service to said message. In Python, you can read any variable from anywhere. Changing its external variable is a bit tricky though, as it would require you to declare it as a global inside of the function. You can also return a singular object from said function, whether it's a value, a list, or even an object. Other programming languages will require you to precise what to return before naming the function, such as int name open parentheses, put arguments in there or don't, open curly braces, put stuff inside. Or if you don't really need to return anything, you can just precede the function with void. We've seen functions or methods. Now let's talk about classes. You may see classes as more of a factory who builds blueprints or sub-programs. A class contains variables that are local to each object made from that class, functions attached to that class which are local to that class, and those functions can only interact with each other if they belong to that class. For example, let's say a class car has a certain variable like price, color, model, brand, and functions such as gas to know the amount of gas in the gas tank or mileage. Those are example functions. In Python, at least, when declaring a function belonging to the class, it will need the first argument to be self. This is required for the class to be able to be called in the scope of the class itself, or the object resulting from that class. Other languages such as C# don't really require you to precise the ownership of said function, or so to say. One detail about classes you might be asking yourself would be, if I can make a blueprint or an object out of said class, how can I give it an initial value? In Python, you need to define what's called as an init function, written double underscores, init, double underscores, and your parentheses, without forgetting the self and any arguments you will be declaring inside of the said object. In C#, you will need to make a function with the same name as the class, with every other detail mentioned before, disregarding the self. This was a bit of a long one, but hopefully it was not too dense information-wise. I will see you on the next episode, where I will be explaining the uses of different programming languages. Those the reason why screaming at a yeah, I did it. Say for some reason your calculator acts